Hello and welcome back to a new video in my C++ tutorial series. In the last video we talked about the memory and how the stack works. So basically how memory management works, where all of our variables are stored so that you have a bit of basic knowledge on how memory works. And in today's video we're gonna expand on that knowledge and introduce pointers. So pointers is probably why you might come to this tutorial without even watching it. So I guess like many people have issues with C and C++ pointers, so they're gonna Google or YouTube for C++ pointers and they're just gonna find that video. If you are one of these people that just found that video, make sure to at least also watch the previous video that's gonna be linked about memory. Because the memory video is important to understand how pointers work. Only if you understand how the memory works, you understand what pointers are. Actually, like everything you need to know for pointers was already contained in the memory video. We're just going to expand on that, show how it works in C, and of course also in C++. Currently we are only using C here, but the syntax is the same in C++. It's completely the same. Works with both languages, C and C++. And yeah, basically today just a bit of C++, and we're gonna have a problem why we wanna use pointers and a bit of that. But before we can get started, we wanna make sure to create a new project, because pointers is kind of like now a side topic. We are stepping away from our simple C app that is doing some computations that we used previously, and now we are basically wanna step away from that simple C app and we wanna learn much about pointers. So many pointer videos, a few videos about pointers, I think like 2 or 3 probably. And probably 3, yeah. So we're gonna basically have a few videos about pointers in a side project, and then we're gonna take what we learned about pointers and apply it to our simple C app so that we can then properly do everything what we want. Alright, so let's get started by creating a new project. Currently we only have the simple C app, which is like this piece of code. Right, this main function, the function f, the function printfx, this is like our main, our simple C app. And now what we want to do here is we want to create a new project. How can we do this? Well, we're going to select the solution here in Visual Studio. So click on the solution, CCPP tutorial, right click it, select add, new project to create a new project. Inside this add a new project wizard, you should also have this empty project down here in the recent project templates if you created the solution like I did it in the video where we created our first Visual Studio project. And what you want to do here is select that and click next. If you don't have it here, you can basically just go down here to the drop down, select C++, and the first one should be the empty project. So just select any of these empty projects you're going to find, click next to go to the next window, and now you need to make sure that you set up everything correctly. First, we want to verify that the location is correct. By default, if you followed the tutorial along, this should be already where it needs to go. So it should be basically the directory where your main solution is. If you want to verify that this is correct, you can push this browse button with the 3 dots. So it opened now up the folder where it basically wants to create the project, and you can basically see that if we take a look at this, we have the 01 simple C app, and you want to actually make sure that this the directory is in existence. So if this directory is there, you know that you are right. If you are somewhere like that, you made something wrong. If you are like in your documents folder, or if you are inside the simple C app itself, you also made something wrong. But if you followed the tutorial along, you should be in the CPP tutorial, and you can now basically accept this with select folder, or in my case I can just press cancel because I didn't change anything, and we verified that the location, the path where it is gonna be stored is okay. So now we just want to make sure that we give it the right project name. So what name do we want to give it? Well, we're going to follow the same syntax that we've done here. So the first project was called 01 underscore simple C app. So this project now is 02. We are counting up underscore pointers. Now, if you entered the name, you can hit create or push the enter button. If you push the enter button, it's like the same, and it's going to create the project for you. So now we need to do a bit of project setup, because by default, as I already told you, Visual Studio does some settings that I don't like. So first of all, we want to get rid of this filters view. You can do this by basically clicking at the button here, show all files. By pushing that button, we are now basically having the same view that we would get if we would open this up with the Windows Explorer. So basically all files in there, and not like this Visual Studio filter stuff that nobody wants, really, actually. So if you have done this, you can now start by configuring the project. How can we configure it? We're going to right-click it and select Properties, because we want to set these two options here, Output Directory and Intermediate Directory. Now, we already set them up previously in the 01 Simple C app. So we can basically, while this window is open, click on the 01 Simple C app project, and it will automatically switch to Simple C app's properties. And now you can basically see that we now have these custom things that we have entered previously. The nice thing is that I have used these macros, basically the $sign, open brackets, some label, and close brackets. These are macros or variables, however you want to call them, and they will be automatically populated depending on the configuration, the project, and everything that you basically have set it up. And this is nice because this is universally usable. It doesn't depend on your system, it doesn't depend on that. You can use basically what I've used if you like the style. You can just copy paste this to your own project, no matter if it is for the tutorial or for anything else. They out of the box work. So what we can basically do is we can select everything and copy this with Ctrl-Z or right-click copy. And what you then can do is you can now go back to the 02 pointers, and now you can see you're back at the normal options. Now a quick thing that you want to make sure is that at configurations you have all configurations selected, and at platforms you have all platforms selected. And what you then want to do is highlight everything that you have in your output directory and paste in the text that you have just copied. You can press enter to basically confirm your entry, hit apply to save the changes, and then you can go back to the 01 Simple C app, copy the second one as well, go back to the pointers one, select everything, paste it in, go out of it, hit apply, done. One more thing that I want to do is set up the target name. The target name basically was Simple C app here. I specified this target name manually because the project basically has the 01 and 02, and they don't like to have this in my exe files. So I want to do the same thing on my pointers project. So I go to the project and the project's name. I'm just going to say pointers. All right, or not project name, target name, because it's a name for the target executable. And basically the file that Visual Studio is going to output is this target's name plus the type of the application, which is, or the type of project, which is in our case an application.exe, and then basically mix and match these two together to create an output file. So now you want to hit apply again and hit OK, and now you have successfully configured a new project. Now we want to start by adding some files to it. So basically I'm going to select the 02 Simple 02 pointers project, right click it, select add new item to create a new item which I want to add to the project. In the new item dialog, I'm going to select CPP file, even through via C. But if you would do this in C++, it would be 100% the same. We are currently at code that works the same in C and C++, while we are always writing it so it works in both languages. We just start with C to start very gracefully and later on go to C++ for the advanced features. Alright, so what I want to do now is I want to add a new file here, a new source file, where we're going to write our code in. So how I'm going to call this? Well, I'm going to do it similar to the Simple C app. The Simple C app had one single source file, simple C app.c. So the pointers project is going to also have one single source file called pointers.c. Pointers.c. And even though we selected C++ above here and it suggested the CPP ending, if you take as an ending a .c file, it will automatically detect that it is C and it will not change this to CPP. So you can press add or enter to add this new file to the project. And now you have that empty pointers.c file. Now we want to get started writing our main function. First of all, I want to include everything that we included previously because we're going to need these both. You can go to the Simple C app and just copy them and paste them over. For the main function, I'm just going to write it down myself because deleting everything that is inside the other one is like equally as much work than basically writing it from scratch. So our main function was int main open close brackets, new line, and curly brackets open and closed. So this is now our main function, and now we have a valid C application. How can we test this, that it is a valid C application? Well, we could try and press local Windows debugger. Now you would expect that the console window opens and nothing is in it. But as you can see, it opens and it gives us some output f from 5 equals 55, f from 10, and so on. So basically we are still getting the output from our Simple C app, even though we now just create a new project. And that's an important concept of Visual Studio, because Visual Studio has one so-called startup project. The startup project is basically the project that is going to be executed when you hit this local Windows debugger button, or you're going to press F5. If you do this, it's going to start the startup project. The startup project is the project that is highlighted here in the Solution Explorer. So here on the right in Solution Explorer, if we take a look at the 01 Simple C app and the 02 pointers, you're going to notice that the 01 Simple C app is written in bold or highlighted, which basically means that this is the startup project. The 02 pointers, it's just a normal font, just like the text here, like in pointers in the folder exercise. It's all very, very plain and normally written. Just the 01 Simple C app is highlighted because it is the startup project. Now you have two options to start the 02 pointers. You could do this manually every time you want to start it by right-clicking it and saying debug, start new instance. If I do this, it's now going to compile 02 pointers and it's going to open up the debug console. And inside this console, we're going to have no content because our application does nothing. This is one option, but the issue here is that you always need to start it. It works if you want to just quickly test something or simply run a tool that maybe sets up some values or creates some files for you. You might be good by just simply starting this with start new instance and it's good. But we are now going to work on this very frequently and we're going to start and stop it many, many times. And because of that, we want to actually change the startup project so that it automatically starts this project. How can we do this? Well, it's very simple. The first thing you want to do is you want to click the project 02 pointers. You want to right click it so that you can open up the context menu. And right above this debug instance or this debug menu point that we had, we have an option called set as startup project. If you hit this one, if you click on it, you can see now the 02 pointers is highlighted. If I now would press F5 or click the local Windows debugger, we now get the same output that we had from the previous run where we started it manually. We have the output of the 02 pointers project. Alright, and now we are ready to start writing some code. Alright, so what is the purpose of the application that I want to write? Well, basically what I'm gonna do is I'm gonna create a few integers. I'm gonna create two integers. The first integer is gonna be a sum, which is gonna be starting at 0. And the second integer is a num, starting at 0. So what is the purpose of this sum and num? The sum is, I'm just gonna comment this, is the sum of all values, and the num is the sum is the number of sums. So basically the idea is I want to calculate a mean value, an average, and I want to do this by accumulating each value that we get to the sum and also keeping track how many values we added to the sum by basically providing it down here in the num. So basically what I want to do here at the end is I want to have some average, avg for average is equal to sum divided by num, so that it can have an average value that I then can printf here, and I can print this basically by saying the average is, and then I'm basically just going to say what the average is. And now it would be tempted to do something like that, but this is not going to work because we are now having this int 64t, and this int 64t basically means that we have a big integer, but this I here is just for a normal integer. You can, I think, do this like that. I'm not quite sure. Or was it DLL? DLL seems a bit LLD. Was it like that? I think it was LLD. Yeah, LLD basically means this is a very long integer. Just probably LLI also works. Now that I have the order, it's a bit more consistent if I would write I here. This is just some bad headaches and trash that you need to deal with when using the printf function. In the future, we're going to transition to C++, and C++ is automatically detecting the type that you're going to give it, and it's working a bit better. Basically, in C, we always need to tell it what the type is, and C++ is going to make this a hell of a lot easier. But for now, just say this is just used here for outputting the average value. All right, so what would happen if I start this? It crashes. Why does it crashes? It actually tells us right away integer division by 0. So basically the idea is that you cannot basically divide by 0. That's not possible. So basically what we would needed to do is we needed to do a simple check to check if our values are correct, but we haven't talked about if and else and how you can do conditional stuff. We haven't talked about this yet. We're going to talk about this in the future. And yeah, so I'm just gonna assume that we do something here. So we have a to-do here that we're gonna fill so that this issue is gonna go away. Alright, so how would this work if I now have a value that I want to sum up? So let's, for example, say we have a value v0. Oh yeah, let's just keep the condition and starting and counting at 0 because we programmer do start counting at 0, so I'm gonna start here right away. So v0, the value 0. So the value 0 could be, for example, 10. So how would this work if I now would want to change the sum? So what I basically would write is sum equals sum plus v0, and then I would say num equals num plus 1. This is basically everything that I would need it to do to basically add a value on top of that here. So if I would run this, let's see, average is 10. Here we just had one value which was 10, so that's actually good. Let's do this again. So let's do an int64t value 1. Second value, which is going to be equal to 20, and the sum is going to be equal to the sum plus the value 1, and the num is going to be equal to the num plus the value 1. If I would run this now, you can see that the average now is 15, because if we would do the math, let's open up a calculator, 10 plus 20 divided by 2 is 15. Average is 15, so that's actually working. So very, very nice. But as I already told you, code duplication is bad. We want to write as efficient code as possible. So we want to write simple and easy code. There are a few ways how we can simplify the code. You're going to get one as a bonus, even though this is the pointers video. Actually, to what you basically see here, you're going to see basically sum equals sum plus value. And what we can do is we can actually shorten this up by writing sum plus equals. Plus equals basically means add something on top of the sum. It's just a bit more straightforward. Same here with num. We are basically adding 1 to the num, so basically we can say num plus plus. Num plus plus is basically incrementing this by 1. So basically we are saying plus, and plus plus basically means that this is interesting. A simple pun, I always like to joke and call my variable c so that I can write c++. Ha ha ha, no, little joke. Okay, so yeah, that's basically how you can simplify this so that it is a bit more easier to understand. If we would write this code down like that and compile it, it's gonna give us the same output, right? It's just a bit simpler. Just makes this a bit more readable. Incrementing plus plus works, minus plus equals work. What's also working is if you would basically, it's not just working like plus equals, you can also do it minus equal, multiply equal, divide equal. This is all something that works as well. Also, you can do, of course, not only num plus plus, but also minus minus to decrement stuff. So basically, it's just a bit simple shortcut, and it gives us a few more options than we have seen here. Alright, so now what you basically would want to do is you would want to factor this out to a function, right? Because basically what you have here is code duplication. It's all the same, and we don't want to write this always. So let's write a function for that. So what is the return value of the function? Well, actually, I don't want to return something. I just want to change values, right? I'm not returning anything. I don't have any positive feedback from that. I don't have any feedback. I just do something, right? So let's write this function. So we're going to write a void, and we can say accumulate, because basically we want to accumulate values, and then this is going to be correct. This is actually written correctly, accumulate. I have no idea if yeah, it's probably, is it written correctly? What's the right one? I've written this correctly. Yeah, that's interesting. So basically what I want to do is I want to accumulate. What do I want to accumulate? Well, basically I want to accumulate to my sum, my num. I want to accumulate a value. Sum and num, and this is going to be the value. So how is this going to work? Well, we could just go and take it and write it down here. Now we don't need the v0 because it's already there. We can say sum plus equals value, num plus plus, and it seems like we would be good. So what we could now do is basically we could call the function accumulate with the sum, the num, the 10, and the 20, and we will think that we are good, right? Because we are doing everything that we have done previously, but now we are doing it in a function. Let's press F5 and see what we get. Well, we get nothing. integer division by 0. So we are getting the same issue again. Why do we get it? Well, let's try and track this down. How can we track this down? We track this down by setting breakpoints. Breakpoints before we do something. So I'm just going to put a breakpoint before we do the first accumulate, before we do the second accumulate, and before we compute the average. So let's now hit the local Windows debugger and see what we get. So by default, you can basically see that Visual Studio is, as soon as we go into the breakpoint, showing us the values of our variables. You can also hover over them to see the values, but it's easy seen here in the outline, where you can basically see all of them in this list here. You can see that we have an int64 and it's called num and the value is 0. We have another int64 called sum and the value is also 0, which is right because we just initialized them to 0. Now what you can basically do is you can hit this continue button, and this continue button is going to run until it finds the next breakpoint. So I click continue, and as you can now see, the values are still both at 0. So this doesn't work actually. If I would continue again, you can see, well, it doesn't really do anything. The values are still at 0. Now it automatically also created that average value, which is currently at 0. And if I would continue, we would run in that unhandled exception integer division by 0. So as you can see, basically the accumulate did nothing. Can we drag this down even further? Yes, we can. We can now also put some breakpoints inside of that function. I'm going to put 2 of them here. One at the beginning of the function and one at the end of the function. That should be good. So now I can hit the play button to see what's going on. So now we should go into our first accumulate. So I'm going to click continue to jump into that computation. All right. So now we are inside of that here, and you can basically see what we got. We have the num value, the sum value, and the value. Value is at 10. This is correctly because we basically inputted 10. We also have the sum and the num, which is at 0 because, well, we passed the values here and initially they were 0. So now I can hit continue and see what it does. All right. So the function executed. We are now at that breakpoint here, and as you can see, the value is still at 10. Yeah, right, we didn't change it. The sum is at 10 because we accumulated to it, and the number is at 1 because we have incremented it. So everything works actually in this function. But if I would now hit continue again and jump out of that function, you can see that num and sum changed back to 0 again. Why is that not working? Well, why is it not working? Because how the stack works. I told you how the stack works. So basically, to revisit that, for that current example, let me open up a notepad. Actually, have I installed Notepad++ here? No, I have not installed. What is wrong with me? Why didn't I have installed Notepad++ in the first video where we installed development tools? But yeah, we have Visual Studio Code, right? Yeah. So how does the stack operate? So basically, I told you that the stack basically starts at an address. We're just gonna pretend the address to be 0x00 here. Maybe just 2, 3 digits here, or 4, just out of curiosity. So this is basically now our stack. So what do we put on our stack? We put on our stack sum equals 0. Then this is a 64-bit integer, so it means that it is 8 width, so it's going to be at 8. So now we're basically going to put the num on here, and the num is going to be 0 as well. So now we are going into, maybe let me type in where we are. So basically main. Let's do this like this. So basically in our main function, we have put the sum and the num on the stack. Now we are calling our function accumulate. And if you are remembering the last video about memory, we are now into the accumulate function. I'm just going to shortkey this with accu so that I am have correct width here. Actually, let me accumulate. There we go. Like that, so that this is nicely formatted. So there we go. So now we are in the accumulate function. And what does the accumulate function does? The accumulate function needs 3 parameters. So these parameters are actually copied for that function accumulate. So basically we are now at 10. This should be correct if I'm not mistaken. Anything? Okay, I shouldn't have used tabs here, so that this is in line like that. And basically what we are doing now is we are basically copying the sum for the accumulate function. So we are creating another copy of that sum, which is going here to be the same value than we had the sum up here. And what we now basically do is we do this the same again for the number value. So we have, I didn't wrote a tab again because I'm an idiot. So we do the same for the number. We also put 0 in here, copy it over, accumulate, and accumulate. And now we have another value that we need for that function, which is the value, and the value is going to be 10. So basically this is what we ended up with the stack as soon as we started executing the accumulate function. What happens now is when we're computing the sum, we are basically saying the sum is equal to sum plus value. So sum is equal to sum plus value. So sum basically is equal to 0 plus 10 equals 10. So basically what we are doing here is we are only operating on that sum value that has been copied for the accumulate function. Now basically now our accumulate value is here at sum. The 10 is at sum in the accumulate function. Now what we are doing is we are incrementing the num plus plus, which means num equals num plus 1, which is 1. But as you can see again, we are only doing these changes on the copy for the accumulate function. So basically, now we are done with our computation. Everything was correct. But now we are returning back to the main function. And by returning back to the main function, the stack is unwinded, which basically means that all of these computations that we have just done are discarded. They are discarded and thrown away. Right? Thrown away into the trash. And this is why this function doesn't work. How can we solve this? Well, basically what we need to do, instead of directly passing the sum here, we basically need to tell our accumulate function where to find the sum, where to write the sum to, where is basically the sum located. So we don't really want to write the value of the sum down here, because these values, these have names, but for the CPU, when the program is compiled, they no longer have names. They are just having addresses, offsets in the stack, and stuff like that. These are just offsets. These are not names. The names are completely trashed. So basically what we basically need to tell is where this sum is stored. So instead of putting the sum in here directly, we basically want to tell the accumulate function where it can find the sum. And how can we do this? Well, we basically do this with pointers. And the pointer is nothing more than an address. So basically, instead of putting the sum in here, we basically want to tell the function where to find the sum. So if we want to go to the initial state again before we execute the function, now instead putting the sum in here, we're basically going to tell it that we're basically going to have the int64t, and this int64t is going to be at a certain location, and in this case, it is going to be at this main. So we're basically going to say it's at main, and this basically means that this value is going to be equal to 0x00, because this is in our case the address of the sum. This is just here in the notepad, right? In the reality it's completely different. And we want to do the same thing here with the number as well. So we basically want to say we have a, okay, we should maybe do this like that. So sum is basically here an int64t value that is stored there, maybe like that. So we want to do the same thing here as well. So we want to tell it that the number is an int64t value here at main, and it's going to be equal to that address here. So basically to the address to the number. And what now happens if we have addresses here, what basically we are doing is now we're going to go in here. So sum plus equal the value. All right, sum is an address which is stored at main. Okay, so I basically now know that the sum is stored here. And what I basically now do, instead of taking this value for the computations, I'm going to take that value for the computation. I'm going to say, all right, this is equal to 0 plus 10 equals 10. So I am going to write 10 in here. Then I want to increment the num. So num is stored at 0x008, which is here. And I'm going to say, okay, this is equal to plus 1, which is basically 1, and I'm done. Now I'm basically unwinding the stack. This gets trashed, and we are left with the correct values. Now for the next iteration, I would go in here again. These ones are going to stay the same, but the value now is going to be put to 20. All right. So we are doing the computations. 10 equals 10 plus 20 equals 30. Num equals 1 plus 1 is 2. And we'll basically store them. Unwind the stack, and we are still left with the correct values. So the idea is basically to tell the application where to find the value instead of the value directly. So basically we need a syntax to basically tell that the sum and num is not an int. It is basically a pointer to an int, an address of the integer, where that integer is stored, wherever it's stored. wherever in memory it is stored. And we can basically do this by adding a special char, because currently we have it in 64T. This is the type. The type is still the same. This is always going to be a 64-bit integer. But now we are not having a plain integer, but we are having a pointer to an integer. And the pointer is going to be indicated by that star. And by putting that star above here, we basically tell the compiler that this is an address, a pointer. It's the same. From now on, we're going to use the term pointer, but the pointer is really just an address. As is a bit more, we also have some information here. We have an information that's in 64T, but behind that is an address. So basically, I'm going to say, all right, the sum is going to be an address and the num is going to be an address. All right, good. What would happen if I run this now just by putting the pointers in here? Well, it will basically still do the same. Right, let me quickly step through this, and if we are down here and execute this, we are still going to have our integer division by 0. Why do we have them? Well, basically because we have not used that pointer. We have basically said that this is going to be a pointer, but we have not used it in the way we use pointers. If I would go here to the right to output and switch this from debug to build, we're going to get some errors. We're going to get a warning here. Function differs from level of indirection. If I double click this here, you can basically see that it is gonna give us something. You can basically, it tells us int64d differs in level of indirection from int64t. So basically what we have done, we have given it an int64t called sum, but it expected an int64t pointer. It's not an issue. The compiler, the C compiler is really not having a problem with that. It's giving us a warning, but it's not having a problem. It basically takes this value and interprets it as a pointer. And if we would try this out again, so go in here, you can basically now see that num and sum are now at 0x00. And you can now see that it is actually shown differently. It is now shown here with these long values, these hexadecimal. You can see that we can open this up, and if we open this up, it says unable to read memory, because it's basically automatically trying to detect this as a pointer. However, we have passed in 0, which is something called a null pointer, and this null pointer basically stands for no pointer or invalid value. It is null, it is not defined, and that's not really what we want to do. We basically want to pass the address here, and we didn't do this because it interpreted the 0 as a pointer. So how can we pass the address? Well, we basically need to write a special char to tell the compiler to not take the value of the sum, but to take the address of the sum. And that special char is the ampersand. The ampersand, if we're going to put this before the sum and the num, everything is going to be all right. If I now would try to rerun this, and also step again in here with the debugger, and would now continue here by clicking on continue and go into the accumulate function, you can now see that the number is no longer 0. It is 0x000. How many zeros there are? I know 7A7C2FF778. And here another value which is also in the same range. And you can now basically see that these are very, very strange values. But if we open them up, we can open them up by pressing enter while this is selected, or clicking the uncollapse button here. We can actually take a look at the value, because if we uncollapse it, we're going to see the value. It's already shown behind here in the curly brackets, but if you open these up, they are going to be a bit more uniform and a bit more how you would expect them. And you can see that the value of these are 0, which is correct because sum and num is 0. If I would now continue the execution of the function, you can see that everything gone wrong, right? But now we would basically expect that sum is still the same pointer, but the value in here would be 10, and that, sum down here is still the same pointer, and the value in here is gonna be 10, and num is still the same pointer, but the value is 1. However, we do have some strange new address and some strange values in here. Why is that? Well, it is because we have not used the correct value. Basically, what we have done is pointer arithmetic. So basically, instead of taking the value of sum and incrementing it by 10, we basically move the pointer 10 values ahead. So basically, what we have done now, instead of changing the sum here, we have basically taken that sum pointer, which was basically here. Let me maybe copy this like that. So sum basically was the pointer here to 0, and what we have done, we have incremented this by 10, which is hexadecimal of A, which is basically now like that, and now it's basically some invalid value inside of our main, or maybe let's do this like that. It's basically now something, it's no longer the sum. It's still named sum, but it's no longer the sum. It is somewhere inside of our main. We don't know where it is. It could be a future value, a different value. If we do something wrong, we might overwrite values that we have already set, and it's really not a good idea. So basically, by just changing the pointer, we are not doing anything. We are changing the pointer, basically the address where we stored it. But what we want to do basically is we want to store or change the value, not the pointer. And how can we do this? First of all, let's step out of debugging by pressing the red box button here. What we basically want to do is we want to tell the compiler to go one level back. We use that ampersand to go one level further, and you can also do this. Of course you can do this. You can put an ampersand always. I could use like a pointer to 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 a pointer. It's not really keen on doing that here because it doesn't like the idea of that, but I could do this, right? I can... I think if I'm, yeah, well, it cannot really get the pointer here to some, this is a different issue why this is not working here, but you could do this infinitely. You can create a pointer to a pointer, and then you can store this and create another pointer to it, and you could go with level in direction and addresses how far you want to go, right? But what we basically now want to do is we don't want to get the address of it, because ampersand means address. We want to go one level back. We want to take that address and go to the actual value of that address. Actually take a look at where's the address pointing, where's the pointer pointing, and modify that value behind the pointer. How can we do this? Well, we are gonna do this with that pointer symbol again, but now we are not adding this to the type. Here I have added this pointer symbol to the type. I have directly added it here after the type name here, before the sum. It would be also possible from a syntax to do this like that, but I don't like this because that and that looks the same but is something completely different. So what I like is to have it always like that. And this basically means don't modify the pointer, modify the value. So having the star here means modify the value, not the pointer itself. We can do this down here at the num as well, and to make this always a bit more readable, I always like to do it like that. So I like to put brackets around so they can basically see that we are going basically one level back and then incrementing it. So basically having this like that should do the trick. Right? If we would try this out now, maybe let's put these breakpoints in again, sorry. I can do this while it's running as well. So now you can basically see that our num is 0 and our sum is 0. And if we are now going into the accumulate function, you can see that we have the num and sum pointer. The num and sum pointer, they are both 0. It's behind these brackets. And now we basically want to accumulate to that sum, and then we want to increment num. And if we do this now, you can now see that it is different. Now this is one thing that I don't like about this view. This view is basically trying to predict what you want to see, but the thing is I don't want to get predictions. So what I'm going to do is I'm going to quickly switch to locals. The switch to locals makes sure that everything is exactly how it is laid out. So these locals tab is basically showing you everything that is in scope, in this case the sum, num and value, while this auto stuff tries to predict what you actually want to see. But in this case I do want to see everything that is in local. And now you can basically see that the num and the sum pointer is still the same, but the values have actually changed. Now the sum, still the same value, but the value behind that pointer is at 10. The num, basically, the pointer, still the same value, but the value behind the num is now 1. If I now continue, you can actually see that inside of our main, now our num has incremented to 1 and the sum has been accumulated to 10. And if I go through, let's maybe remove them now, I don't need them, go through another run of the accumulate function, you can see that the sum now is 30 and the num is 2. And if I hit continue again, it now can compute the average and it can output the average as 15. And now I could go in and accumulate as many values as I want, so 30, 40, 70, yeah, something like that. I can do whatever I want. I can press a 5 and it should always work and give us the average of 40, which is probably right. I'm not going to recompute if it is right. Right? No, right, wrong, whatever. Alright, so let me revert this. We just need 2 here for the example. And let's take a look at the code again. Alright, so basically, just as a summary here, we have created 2 variables on the stack called sum and num. We have created a function that takes a pointer to a sum and the pointer to a num, as well as a value, which is also called value. Bad namings, but yeah. And basically what it does, it takes the value of the pointer, not the pointer itself, the value behind that pointer, and it adds the value to that, and it increments the value behind the num by 1. So very simple code, very simple, pointers explained. And if we do here normal computations, if we press a 5, everything should be as expected. It's going to compute the average just fine. So a few important concepts about pointers, right? There are a few things, takeaways that you should get here with that video today. And these are a few ones. Step 1, important thing number 1, pointer types. Pointer types. A pointer type is always declared by a type and a star. This type can be everything. For example, here I could have, for example, an int64t star for a pointer. And this basically means that this is a pointer. Pointer to a value of that type. Now, if you want to modify the value, not the pointer, so modify the value, I want to basically have the variable dereferenced equals whatever you want to do. So if I would basically have a int64t pointer p, that is going to be some value here, and I want to modify the value behind the pointer, I need to dereference p to set the value to 5, for example. Third takeaway, creating pointers. How can I create a pointer to an existing memory? If I have an uint64t value equals to 0, and I want to create the pointer t, and I want to create the pointer p, and I want to create the pointer p, I need to basically now say, first of all, I declare pointer type, so pointer here again, p equals ampersand value. So ampersand creates a pointer to the value. And now, of course, I can say dereferenced p equals 5. These are the 3 important things. Pointer type needs a star behind the type name. Ampersand is used to create a pointer to an existing value. And the star with a pointer is used to dereference the pointer and directly modify its value. Modifying pointers itself, not the values, very simple. Just assign them, use math. Multiply them, add something here, whatever you like. You can go mad with these. You have so many options and everything you can do. Very, very powerful. And that's the most important thing that you need to understand in C++, pointers. So that's it for today. These are pointers, and this is going to be our nice little git commit, added pointers. And we can now commit this, push this, and we are done for today. Thank you for watching. In the next video, we are gonna explore a bit more on pointers, and we're gonna get a new type of pointer in the next video. So thank you for watching. See you in the next video. Make sure to like and subscribe, and have a nice day. Bye.